Ever wondered how we can predict future trends based on past data? Welcome to the fascinating world of simple linear regression, a statistical method that helps us understand and predict the world around us. Simple linear regression is a concept that might sound complicated, but let's break it down. Simple here refers to the fact that we're dealing with just two variables. Linear means we're assuming a straight-line relationship between these two variables, and regression is a fancy way of saying we're trying to find the best fit for this straight line. So what are these two variables we're talking about? In the realm of simple linear regression, we deal with one dependent variable and one independent variable. The dependent variable, often denoted as y, is what we're trying to predict or estimate. The independent variable, usually represented as x, is the variable we believe has some influence on our dependent variable. For instance, let's consider the relationship between the time spent studying and the resulting exam scores. Here, the exam score would be our dependent variable. It's what we're trying to predict. The time spent studying would be our independent variable. We believe it influences the exam score. Simple linear regression is like a tool that helps us draw a straight line that best fits our data points. This line can then be used to predict future outcomes. It's like looking at a trail of breadcrumbs and trying to predict where the next crumb will fall. This method is used extensively in various fields, from economics to medicine, for making predictions. For example, economists might use it to predict future GDP based on past trends, or doctors might use it to predict a patient's recovery time based on their current health parameters. So, to sum it all up, simple linear regression is a statistical method that helps us understand the relationship between two variables. It's a way of looking at past data, finding a pattern, and using that pattern to predict future trends. With simple linear regression, we can forecast future trends based on past data. So let's dive deeper into this concept and see how it works in the following scenes. Let's dive deeper into the two variables involved in simple linear regression. To better understand simple linear regression, we need to get acquainted with the two main characters of our story, the dependent and independent variables. These two variables share a special bond, a relationship that we aim to explore and understand through simple linear regression. The dependent variable, as the name suggests, is the variable that depends on another. It's the variable we're interested in predicting or estimating. You could think of it as the question we're trying to answer. For example, in a study on how sleep affects academic performance, the dependent variable could be the student's grades. We're trying to see how they might change based on different factors. And that brings us to the independent variable, the variable that stands on its own. This variable is the predictor or estimator. It's the one we believe will influence or cause changes in the dependent variable. In our sleep and academic performance study, the independent variable could be the number of hours a student sleeps each night. We're hypothesizing that this variable, sleep, might have an effect on our dependent variable, the student's grades. In the context of simple linear regression, we're looking at a scenario where we have one dependent variable and one independent variable. It's a one-on-one relationship. The goal here is to find a linear function that, as accurately as possible, predicts the dependent variable values as a function of the independent variable. Keep in mind that this is an oversimplification for the sake of understanding. In reality, many different factors can influence an outcome, and these factors often interact in complex ways. But simple linear regression helps us start to untangle these relationships and see how one variable might relate to another. So before you jump into a simple linear regression, take a moment to identify your dependent and independent variables. Understand their roles and how they might interact. Identifying the dependent and independent variables is the first step in simple linear regression. But how do we make these predictions? Well, we turn to our trusty regression equation. This equation is our crystal ball, allowing us to predict the future, or at least the future as it relates to our variables. The regression equation in simple linear regression takes on the form y equals alpha plus beta x, or y equals sine alpha plus bx for short. Each component in this equation has a special role. Let's break it down. First, we have y. This is our dependent variable, the one we're trying to predict or explain. It's the variable that we believe is influenced by our other variable, x. Next, we have x. This is our independent variable. It's the variable that we think has an impact on y. This is the variable we manipulate or observe to see how y changes in response. Then we have alpha. This is our y-intercept. It represents the value of y when x is 0. It's our starting point, the value of y, when none of the independent variable x is present. Finally, we have beta. This is the slope of the line representing the rate at which y changes for each unit change in x. It's a measure of how strong the relationship is between x and y. If beta is large, a small change in x can lead to a big change in y. If beta is small, y changes at a slower pace as x changes. In essence, the regression equation is a mathematical representation of the relationship between our variables. It gives us a way to quantify this relationship and make predictions based on it. By plugging in a value for x, we can predict the corresponding value for y. And that, my friends, is the power of simple linear regression. Remember, the beauty of the regression equation lies in its simplicity. It's a straightforward yet powerful tool that allows us to peek into the future, giving us insights that can help us make informed decisions. The regression equation is the key to making predictions in simple linear regression. So, what do the slope and intercept tell us? This is the question that brings us to the heart of interpreting regression equations. Let's start with the slope. The slope is like a translator, converting the language of our independent variable into the language of our dependent variable. In simpler terms, the slope represents the rate of change. If we move one unit along the x-axis, how much does the y value change? That's what the slope answers. So if you have a slope of 3, for instance, for every single unit increase in your independent variable, the dependent variable will increase by 3 units. But what if the slope is negative? A negative slope indicates an inverse relationship. In this case, as the independent variable increases, the dependent variable decreases. The steepness of the slope, whether positive or negative, tells us about the strength of this relationship. A steeper slope signifies a stronger relationship between the variables. Now let's talk about the intercept. The y-intercept is the starting point. It's where our line crosses the y-axis when the independent variable is 0. It's the value of the dependent variable when the independent variable doesn't play a role. For instance, if we were looking at a relationship between years of experience and salary, the y-intercept could be the starting salary. That is, the salary when the years of experience is 0. However, it's important to note that while the intercept can provide valuable information, it may not always make sense in the context of the data. For instance, in a study measuring the effect of age on a particular health outcome, a y-intercept might represent the predicted health outcome at 0 years of age, which may not be meaningful or relevant. So in essence, the slope and intercept are the storytellers of our regression equation. They tell us about the nature, strength, and direction of the relationship between our variables. Understanding the slope and y-intercept helps us understand the relationship between the variables. Now let's summarize what we've learned about simple linear regression. Simple linear regression, often abbreviated as SLR, is a statistical tool that allows us to understand and quantify the relationship between two variables. These variables, which we refer to as dependent and independent, form the basis of our regression model. The dependent variable, also known as the response or outcome variable, is what we aim to predict or explain. On the other hand, the independent variable, also called the predictor or explanatory variable, is the variable we believe influences or explains changes in the dependent variable. Our regression model is expressed through a simple equation, which is y equals alpha plus beta times x. In this equation, y represents our dependent variable and x, our independent variable. The coefficients alpha and beta are parameters of the model that we estimate using data. Alpha is the y-intercept, representing the predicted value of y when x is 0, whereas beta is the slope of the line, indicating the expected change in y for each 1 unit increase in x. Interpreting the slope and y-intercept in the context of our data is crucial. The slope, beta, tells us about the direction and rate of change between our variables. A positive slope indicates that as the independent variable increases, the dependent variable also increases. Conversely, a negative slope suggests that an increase in the independent variable leads to a decrease in the dependent variable. The y-intercept alpha provides the baseline value of the dependent variable when all independent variables are 0. Remember, simple linear regression is a powerful tool, but it has limitations. It assumes a linear relationship between variables and may not capture more complex patterns. Also, it is sensitive to outliers, which can significantly impact the slope and y-intercept. With simple linear regression, we can predict the future by understanding the past.